Hello everyone, so today I will be talking about task 3.2c Arduino creating IFTTT trigger tutorial video. So before we get started, the task objective is to build a trigger that works with the IFTTT service, and the hardware that is required for this task would be the Arduino Nano 33 IoT, the breadboard, the light sensors, and the jumper wire cable. So as you can see here in this photo, I have connected the the Arduino, the sensors, and the breadboard according to the Arduino Nano 33 IoT pinout. So as you can see here, what's given on the light sensors, we have the ground pin, SDA pin, which is serial data, serial clock, and the VCC, which is connected to the 3.3 volt. As you can see here, the white cable is connected to the VCC. Black cable, which is A4, as you can see here. As you can see here on the pinout, the A4 or analog 4 on the Arduino pin should be connected with the SDA, which is serial data on the light sensors, and A5, which should be connected to the SCL pin on the light sensor or in the breadboard. So after I have built my circuit, I have created a Hive HQ Cloud account and have connected the web client, which is very crucial for this task because you will be using it in your code. And in your code, as you can see here, there must be 3 libraries included, which is the Wi-Fi Nina, which allows the Arduino to connect to the Wi-Fi, the PubSub client library, and the BH1750. I have used the BH1750 FVI because the normal library, the BH1750, was not compatible with with the light sensors that I have here. So as you can see in the code, we need the Wi-Fi credential, the MQTT broker, and as well as the topic here, the SSL client, the BH1750 light sensors, and the function connected to the MQTT broker. All of this, most of these here are provided to us by the PubSub client library or the MQTT library. And next up, in the white setup area, the code that we have is to initialize the light sensors and connect to Wi-Fi. As you can see, while it's connecting, it says connect to Wi-Fi, and when it's connected, it says connected to Wi-Fi. And in the white loop, we can see here it says to keep the MQTT connection alive, and it'll print out light, which will show us the intensity, the luminosity intensity. As you can see here, print the lux, which is the variable we have given for the light sensor to get light intensity. So as you can see here, if the light intensity is over 1000, it will display as light detected, whereas if it's lower than 1000, it will show us no light, and it detects every 15 seconds, and where there's no light, it detects every 10 seconds, and it'll send the data to your email every 10 seconds. So as you can see here, after you connect everything, this will be the output of the code. It says here connected to MQTT broker, connected to Wi-Fi, and it shows us the light intensity. It shows the light intensity of that was collected from the light sensors. So moving on, I want to talk about this node bread, which is very important in this part because this acts as a bridge from the Hive MQ to your Gmail right here. As you can see here, the light sensors, it says you have to input accordingly, which is the server which is provided from the Hive MQ over here. You have to input this in, and the topic as well as the QoS. And then there's the function which will be given in the okay, as you can see here, the function will input the code which will be given to us from the module, the week 3 module. And over here we put in the Gmail that we want them to send them to, and after that we just click deploy. And after we click deploy, the output that you'll want is it'll send this email to us where it says light alert as according to the code, where if it's the luminosity is over 1000, then it says light detected. As you can see, it says alert light detected in your area. Thank you for watching the video.